Caddy RBS16, a 3-box mounting bracket, has occasionally faced rejection by inspectors. The primary reasons cited for this rejection often revolves around the inspector's perception of the bracket's structural integrity. There are concerns the bracket may not adequately support the combined weight of the electrical boxes and the associated conduit, particularly when using rigid metal conduit, or IMT, with sizes of 1/2 inch or 3/4 inch. Another factor contributing to inspector disapproval is the suitability of the bracket for this specific application. Inspectors might question whether the bracket is appropriately listed or certified for the intended use, raising doubts about its compliance with safety standards and regulations. However, it is important to acknowledge the Caddy RBS16 is generally a UL-listed product. This listing signifies that the bracket has undergone rigorous testing and meets established safety standards for supporting multiple electrical boxes along with their connected conduit systems. Therefore, in the majority of applications, the Caddy RBS16 can be considered a safe and reliable option for mounting electrical boxes. If encountering resistance from an inspector regarding the use of the Caddy RBS16, several strategies can be employed to address their concerns and potentially gain approval. Firstly, contacting the manufacturer of the Caddy RBS16 bracket can provide valuable support. Manufacturers often possess extensive documentation, technical specifications, and application guidelines that can substantiate the bracket's suitability for a particular installation. This documentation can prove instrumental in alleviating inspector reservations. Secondly, being well prepared to demonstrate the bracket's UL listing to the inspector is essential. Providing readily available proof of the UL certification can instill confidence in the inspector regarding the bracket's adherence to safety standards. The UL listing serves as an objective verification of the product's quality and performance. Thirdly, clearly and comprehensively explaining how the bracket will be utilized within the specific application can help address any uncertainties the inspector may have. Detailing the installation process, the types of electrical boxes being supported, and the methods of conduit attachment can provide valuable context and reassurance. Fourthly, offering to provide the inspector with supplementary documentation from the manufacturer can further strengthen the case for using the Caddy RBS16. This documentation may include load capacity data, installation instructions, and other relevant technical information that can address any remaining concerns. By proactively providing this information, the inspector can gain a more complete understanding of the bracket's capabilities. In summary, when facing inspector reluctance regarding the use of a Caddy RBS16 bracket, it is crucial to understand the common reasons behind their concerns. By addressing these concerns through clear communication, supporting documentation, and a thorough explanation of the installation plan, it is often possible to convince the inspector of the bracket's suitability and obtain the necessary approval. Remember, demonstrating the bracket's UL listing and providing manufacturer specifications are key steps in this process. The considerations of box fill in accordance with the National Electrical Code, or NEC, are always critical to any electrical installation, irrespective of the mounting bracket used. Box fill refers to the maximum number of conductors, devices, and fittings permitted within an electrical box. Overfilling a box can lead to overheating, insulation damage, and potential safety hazards. The NEC provides specific guidelines and calculations in Article 314.16 to determine the allowable box fill based on the box size, conductor size, and the presence of devices or fittings. When using a Caddy RBS16 bracket, it is important to ensure that the electrical boxes mounted on the bracket are adequately sized to accommodate all conductors, devices, and fittings without exceeding the NEC box fill requirements. Failure to comply with these requirements can result in code violations and potential safety risks. Furthermore, the proper support of the conduit connected to the electrical boxes is crucial for maintaining the integrity and safety of the electrical system. The NEC specifies requirements for conduit support in Article 344 for rigid metal conduit, Article 358 for intermediate metal conduit, and Article 352 for rigid polyvinyl chloride conduit. These requirements dictate the maximum spacing between conduit supports and the methods of securing the conduit to structural elements. When using a Caddy RBS16 bracket, it is essential to ensure that the conduit is properly supported in accordance with the NEC requirements. The bracket itself may provide some degree of support, but additional supports may be necessary depending on the length and weight of the conduit run. Failure to adequately support the conduit can lead to sagging, stress on the electrical boxes, and potential damage to the conductors within the conduit. Moreover, the grounding and bonding of the electrical system are critical for ensuring electrical safety and preventing shock hazards. The NEC provides comprehensive requirements for grounding and bonding in Article 250. Grounding refers to the connection of the electrical system to the earth, while bonding refers to the connection of metallic parts of the electrical system to create a low impedance path for fault current. When using a Caddy RBS16 bracket, it is important to ensure that the electrical boxes and conduit are properly grounded and bonded in accordance with the NEC requirements. This may involve using grounding bushings, bonding jumpers, and other grounding and bonding devices to create a continuous and effective ground fault path. In addition to the NEC requirements, local electrical codes and regulations may also impose specific requirements for electrical installations. It is essential to consult with the local electrical inspector or authority having jurisdiction, or OJ, to determine any specific requirements that may apply to the use of a Caddy RBS16 bracket in a particular location. Local codes may address issues such as seismic bracing, fire stopping, or other unique conditions that are not covered by the NEC. Compliance with local codes is mandatory for ensuring the safety and legality of the electrical installation. Furthermore, the selection of appropriate electrical boxes for use with a Caddy RBS16 bracket is an important consideration. Electrical boxes are available in various sizes, shapes, and materials, each designed for specific applications. The NEC provides guidelines for selecting the appropriate type of electrical box based on factors such as the number of conductors, the type of wiring method, and the environmental conditions. When using a Caddy RBS16 bracket, it is important to choose electrical boxes that are compatible with the bracket's mounting holes and that provide adequate space for the conductors and devices. It is also important to select boxes that are rated for the appropriate environmental conditions such as damp or wet locations. The installation of the Caddy RBS16 bracket should be performed by qualified and experienced electricians who are familiar with the NEC and local electrical codes. Proper installation techniques are essential for ensuring the safety and reliability of the electrical system. The bracket should be securely fastened to a suitable structural element, such as a wall stud or ceiling joist, using appropriate fasteners. The electrical boxes should be securely attached to the bracket, and the conduit should be properly connected to the boxes using appropriate fittings. All connections should be made in accordance with the manufacturer's instructions and the NEC requirement. Regular inspection and maintenance of the electrical system are essential for identifying and addressing potential problems before they become safety hazards. Electrical systems should be inspected periodically by qualified electricians to check for loose connections, damaged wiring, and other signs of wear and tear. Any problems that are identified should be promptly repaired or replaced to ensure the continued safety and reliability of the electrical system. The Caddy RBS16 bracket itself should also be inspected for any signs of damage or corrosion and replaced if necessary. Continuing the discussion on electrical installations and the use of Caddy RBS16 brackets, it is important to consider the various types of conduit that may be used in conjunction with these brackets. Each type of conduit has its own unique properties and applications, and the selection of the appropriate conduit type is crucial for ensuring the safety and performance of the electrical system. Firstly, rigid metal conduit, or RMC, is a heavy-walled, threaded conduit that provides excellent mechanical protection for conductors. RMC is typically made of steel or aluminum and is suitable for use in both indoor and outdoor applications. It is often used in areas where the conduit is subject to physical damage or corrosion. Secondly, intermediate metal conduit, or IMC, is a thinner-walled version of RMC that offers similar protection at a lower cost. IMC is also threaded and can be used in many of the same applications as RMC. Thirdly, electrical metallic tubing, or IMT, is a thin-walled and threaded conduit that is commonly used in indoor applications. EMT is lightweight and easy to install, but it provides less mechanical protection than RMC or INC. EMT is typically connected using set screw or compression fittings. Fourthly, rigid polyvinyl chloride conduit, or PVC, is a non-metallic conduit that is resistant to corrosion and chemicals. PVC conduit is lightweight and easy to install, and it is often used in underground or damp locations. PVC conduit is typically connected using solvent cement fittings. Fifthly, flexible metal conduit, or FMC, is a flexible conduit that is used to connect electrical boxes or equipment that are subject to movement or vibration. FMC is typically made of steel or aluminum and is available in both liquid-tight and non-liquid-tight versions. The selection of the appropriate conduit type depends on several factors, including the environmental conditions, the degree of mechanical protection required, and the cost. The NEC provides guidelines for selecting the appropriate conduit type for various applications. When using a Caddy RBS16 bracket, it is important to ensure that the conduit is properly supported and connected to the electrical boxes in accordance with the NEC requirements and the manufacturer's instructions. In addition to the conduit, the selection of appropriate wiring methods is also crucial for ensuring the safety and performance of the electrical system. The NEC defines various wiring methods, each with its own unique characteristics and applications. Firstly, non-metallic sheet cable, or NM cable, is a common type of wiring used in residential applications. NM cable consists of two or more insulated conductors enclosed in a non-metallic sheath. NM cable is relatively inexpensive and easy to install, but it is not suitable for use in damp or wet locations. Secondly, underground feeder, or UF cable, is a type of cable that is designed for direct burial in the earth. UF cable is similar to NM cable, but it has a more durable outer sheath that is resistant to moisture and chemicals. Thirdly, armored cable, or AC cable, is a type of cable that consists of insulated conductors enclosed in a flexible metal armor. AC cable provides excellent mechanical protection for the conductors and is often used in commercial and industrial applications. Fourthly, metal-clad cable, or MC cable, is similar to AC cable, but it has a smoother outer metal sheath. MC cable is also used in commercial and industrial applications, and it is often required in healthcare facilities. The selection of the appropriate wiring method depends on several factors, including the environmental conditions, the type of building construction, and the local electrical codes. The NEC provides guidelines for selecting the appropriate wiring method for various applications. When using a Caddy RBS16 bracket, it is important to ensure that the wiring is properly installed and protected in accordance with the NEC requirements and the manufacturer's instructions. Furthermore, the overcurrent protection of electrical circuits is a critical aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from damage caused by excessive current flow. The NEC requires that all electrical circuits be protected by overcurrent protection devices that are sized appropriately for the ampacity of the conductors. The ampacity of a conductor is the maximum amount of current that the conductor can safely carry without overheating. The NEC provides tables that list the ampacities of various conductors based on their size, insulation type, and temperature rating. When selecting overcurrent protection devices, it is important to choose devices that are rated to interrupt the available fault current at the point of installation. The available fault current is the maximum amount of current that could flow in a short circuit condition. If the overcurrent protection device is not rated to interrupt the available fault current, it could fail to clear the fault, resulting in a fire or other safety hazard. Moreover, arc fault circuit interrupters, or size, are a type of overcurrent protection device that is designed to protect against arc faults. Arc faults are dangerous electrical faults that can cause fires. SIs are required by the NEC in many residential circuits, particularly in bedrooms and living areas. Ground fault circuit interrupters, or GFCIs, are another type of overcurrent protection device that is designed to protect against ground faults. Ground faults occur when current flows through an unintended path to ground, such as through a person's body. GFCIs are required by the NEC in many locations where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor areas. In addition to the technical aspects of electrical installations, it is also important to consider the safety aspects. Electrical work can be dangerous, and it is essential to take precautions to protect yourself from electric shock and other hazards. Firstly, always de-energize the circuit before working on any electrical equipment. Use a voltage tester to verify that the circuit is de-energized before touching any wires or terminals. Secondly, wear appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and insulated tools. Thirdly, never work on electrical equipment in wet or damp conditions. Fourthly, follow all safety instructions and warnings provided by the manufacturer of the electrical equipment. Fifthly, if you are not qualified to perform electrical work, hire a licensed electrician. Electrical safety is paramount. The NEC provides specific tables, for example Table 310.15, to determine the allowable ampacities of conductors. These tables take into account factors such as the conductor size, insulation type, and ambient temperature. It is crucial to consult these tables and apply the appropriate correction and adjustment factors to ensure that the conductors are not overloaded. The NEC also provides guidelines for dirting conductors in situations where multiple conductors are bundled together or installed in close proximity. Dirting factors are applied to reduce the allowable ampacity of the conductors to prevent overheating. Understanding and applying these dirting factors is essential for ensuring the safety and reliability of electrical installations.